Okay, so today we are going to discuss derivative of inverse trigonometric function. So we will just recall some important notation. If we have sin y equals 2x, then y is the inverse trigonometric sine of x. So we will write it as y is the inverse inverse trigonometric sine of x, and it is denoted by y is equal to r sine x, or we can also write the notation y equals sine to the negative 1 of x. So this is called the inverse sine of x. So today we are going to calculate the derivative of arc sine x. So suppose we want to calculate the derivative of y is equal to r sine x. Then we can write the equivalent sine function. We have sine y is actually equal to x. So we simply differentiate implicitly with respect to x. So we learned that the derivative of sine is cosine. So the derivative of sine y will be cosine y multiplied by y prime, and the derivative of x is just equal to 1. Solving for y prime, so y prime is 1 divided by cosine of y. But this will be improper because originally we have y is a function of x. So our answer should also be a function of x. To do that, we can use some identities in trigonometry, or we can simply use the right triangle. So since we have sine y equals 2x, we can just construct a simple right triangle here, wherein this is equals to y, and then x, this is equals to 1. And observe that sine y equals opposite over hypotenuse, so it's equals to x over 1. Now by Pythagorean theorem, this is equal to, by Pythagorean theorem, this side equals the square of the hypotenuse minus the square of the other leg squared, and then you just take the square of it. So notice that cosine y is adjacent over hypotenuse. So square root of 1 minus x squared over 1. Or simply square root of 1 minus x squared. And so we now have y prime is equal to 1 over cosine y. Cosine y equals square root of 1 minus x squared. Okay, so in other words, since y is originally equal to arc sine x, so it follows that the derivative of arc sine x is just equals to 1 divided by square root of 1 minus x squared. And by chain rule, if u is a function of x, then we can write the derivative of arc sine u to be equal to this expression 1 over square root of 1, but we replace x by u, so u squared, and by chain rule we multiply by du dx. Okay, you can also rewrite this as du over dx over square root of 1 minus u squared, or you can write this du over square root of 1 minus u squared. To find the derivative of inverse cosine, so or arc cosine, this becomes arc cosine, and then we have cosine y equals to x, and the derivative of cosine is negative sine y, and then we have y prime is 1 over sine y negative. So it is just easy to be able to derive the derivative of r cosine u to be equal to the negative derivative of du over dx over square root of 1 minus u squared. Okay? That's the second formula. And for the third formula, if we want to find the derivative of r tangent x, so this is equivalent to tangent y is equals to x. And by implicit differentiation, okay, we can have here derivative of tangent is secant squared y, and because we have y implies by y prime, and therefore this equals to 1, so that y prime equals 1 over secant squared y. Again, since originally y is a function of x, then the derivative should also be a function of x. To do that, we have tangent y. We can construct another triangle here. Let's say this angle is y, and tangent y is x over 1, so opposite over adjacent. So the hypotenuse can be obtained by Pythagorean theorem. So that will be easily computed as the square root of the square of the legs, the sum of the squares of the legs. And so you will notice that secant y equals hypotenuse over adjacent, so square root of 1 plus x squared. And so therefore we now have y prime equals 1 divided by square root of 1 plus x squared. But since secant y is squared, so we have to square also 1 plus x squared square root. And then this becomes 1 over 1 plus x squared. So since y is equal to r tangent x, then we now have another formula, the derivative of r tangent x is equals to 1 over 1 plus x squared. Okay. So that's the second formula. Now again, if we have u is a function of x, then we can apply chain rule. So this will be replaced by letter u, and don't forget to multiply by du dx, so that the derivative of r tangent u equals 1 over 1 plus u squared times du dx. Now, to find the derivative of r cotangent, you just replace this by y equals r cotangent, so that cotangent y is equals to x, and the derivative of cotangent is cosecant squared y, but it's negative. So this 1 over cosecant squared y. And cosecant squared y is the same as square root of 1 plus x squared, so there will be just a negative in the result. So this is very easy to recognize or derive. So r cotangent u is negative 1 over 1 plus u squared du. So we will summarize this afterwards. And for the last formula number 5, okay, we want to find the derivative of y equals r secant x. So as usual, this is equivalent to secant y is equal to x. And by implicit differentiation, you can see that the derivative of secant is secant tangent. So secant y, tangent y. And since we have y, its derivative is y prime. And therefore this is equals to 1. So that y prime is 1 divided by secant y tangent y. And again, secant y is equals to x implies that if this is an angle y, so we just consider the right triangle angle y, so the hypotenuse is equals to x and the adjacent is equals to 1. Okay, so that cosine x is 1 over x and secant x is hypotenuse over adjacent. By Pythagorean theorem, it is easily calculated. The other side is calculated as square root of x squared minus 1. And so we can see that secant y is equals to x, and then we need tangent y. So tangent y is square root of x squared minus 1. So y prime is 1 over secant y, this is x. Tangent y is square root of x squared minus 1. And again, if u is a function of x by chain rule, we can see that the derivative of r secant u is 1. We replace this by u square root of u squared minus 1, and then don't forget to multiply this by du dx. And finally, if this is r cosecant x, this will be cosecant x, and this will be negative cosecant x cotangent, or cosecant y cotangent y. And then y prime will be negative 1 over negative cosecant y, cotangent y, and we use almost the same triangle, but this one is to be square root of 1 minus x squared. And a little difference is that the difference is there will be a negative sign on that. So 1 over, so negative 1 over u, so the derivative of r cosecant u is negative 1 over u square root of u squared minus 1 du dx. Now, just to give you a brief summary. So, we have the derivative of r sine u. We assume that u is a function of x is equal to 1 over square root of 1 minus u squared times derivative of u with respect to x. Or you can place the derivative of u with respect to x in the numerator. That is just the same, 1 minus u squared. The derivative of r cosine u is just negative of 1 over square root of 1 minus u squared times du dx. So, negative lang ng derivative ng r sine u. Or you can put this in the numerator, so negative du dx over square root of 1 minus u squared. Derivative of r tangent u, this is equals to 1 over 1 plus u squared multiplied by the derivative of u with respect to x, or this is equal to the derivative of u with respect to x over 1 plus u squared. The derivative of r cotangent u is equals to negative 1 over 1 plus u squared times du dx, or that is equivalent to derivative of u with respect to x over 1 plus u squared, but we have a negative sign. Now, derivative of r secant u is equals to 1 over u square root of u squared minus 1 times du dx. And again, you can put du dx in the numerator. So du dx, derivative of u with respect to x over u square root of u squared minus 1. And finally, the derivative of r cosecant u is negative 1 over u square root of u squared minus 1 times du dx, or du dx, derivative of u with respect to x, over u square root of u squared minus 1, but this is negative. So if you notice, arc cosine, arc cotangent, arc cosecant are just the negative derivative of its original function, sine, tangent, and secant, respectively. So we will have some examples on how to calculate derivative of functions involving inverse trigonometric functions. So you may pause the video and then you may take a snapshot of this or copy or memorize the formulas. Okay, so take a look at the example on the board. We have 1 and 2. We compute derivative of y with respect to x. So number 1, y equals arc sine or inverse sine. So remember, arc sine is just the same as inverse sine. So according to our formula, we use the derivative of arc sine u is equals to 1 over square root of 1 minus u squared multiplied by the derivative of u with respect to x. So the entire u is actually this one. So this is our letter u. So if you try to use this formula, our letter u is just equals to x over square root of x squared plus a squared. And of course, if you want to calculate the derivative of u with respect to x, so we have to use quotient rule because we need that in the formula aside from 1 over 1 minus u squared. So we first calculate this, the derivative of u, because we need that in the formula. So denominator, x squared plus a squared times the derivative of x, which is 1, the numerator, minus the numerator times the derivative of the square root function is 2x over 2 the square root of x squared plus a squared. And then all over the square of the denominator, and then you just square that. And then to simplify, you just multiply this by square root of x squared plus a squared square root of x squared plus a squared. So we have to multiply both numerator and denominator by this LCD. So if you distribute this here, so this will be x squared plus a squared, mawawala yung square root. And then this will just cancel. Okay. And then you only have x squared here. And this is, if you square that, this will be x squared plus a squared multiplied by square root of x squared plus a squared, which of course equals to a squared divided by we have x squared plus a squared raised to 3 half, so we just maintain square root of a squared plus a squared, x squared plus a squared. Okay, that's it. So we now calculate the value of y prime. So y prime therefore is derivative of inverse sine is 1 over square root of 1 minus u squared. 1 over square root of 1 minus u squared. So our u is all of this x over square root of x squared plus a squared squared multiplied by the derivative of u with respect to x. Ito na yung nakuha natin. So you have a squared divided by x squared plus a squared square root of x squared plus a squared. And so you notice that y prime is just equal to, so this will be x squared and the x square root cancels out. Then get the LCD, so we just multiply x squared plus a squared by 1. So this becomes 1 over square root of x squared plus a squared minus x squared divided by x squared plus a squared times a squared divided by x squared plus a squared square root of x squared plus a squared. So this will cancel, and this will be square root of a squared, so this is just a, and these two simply cancels out. So what remains will be a squared. So, and you will have here in the denominator square root of x squared, which is just a, then square root of x squared, a squared plus a squared. So this will be a over square root of x squared plus y squared. So that is how we calculate the value of y prime. Okay. Now for the next problem, y equals inverse tangent. Okay, so y equals inverse tangent. We now have here to use the formula for inverse tangent or arc tangent is the same. So the derivative of arc tangent u is just 1 over 1 plus u squared times the derivative of u with respect to x. So this is the entire letter u. So our letter u in the problem is a plus x over 1 minus ax, so a again is a constant, just like in the previous example. And so we have to use quotient rule to calculate du dx. So denominator 1 minus ax, derivative of a plus x with respect to x, so this is 0 and that is just 1, minus numerator a plus x times the derivative of the denominator, which is just negative a over 1 minus ax squared. So simplifying this is 1 minus ax, this is negative and negative, plus a squared plus ax divided by 1 minus ax squared. So ax cancels out. So this can be just written as 1 plus a squared over 1 minus ax squared. So we go back to this. So the derivative of arc tangent is 1 over 1 plus u squared. So y prime is equal to 1 over 1 plus u. This is u. So you have a plus x, 1 minus ax squared, and this is just the derivative of u with respect to x, 1 plus a squared over 1 minus ax squared. So we just distribute this, so this will be 1 plus a squared, this times that, so this will be 1 minus ax squared times 1 plus, so if we distribute this will cancel, so we only have a minus plus x squared remaining. So simplifying further, we have 1 plus a squared divided by 1 minus 2ax plus a squared x squared, and then plus we have a squared plus 2ax plus x squared. So I think we can cancel negative 2ax and plus 2ax. So this is 1 plus a squared, and then we can write this as 1 plus a squared, and between these two we can factor out x squared, and we have a squared plus 1. So this is just also the same as a squared plus 1. So 1 plus a squared, or maybe we can also replace this by 1 plus a squared, because the coefficient of x squared is 1 here, it is 1. So we factor out 1 plus a squared, and then we have 1 plus x squared. So this will just cancel out. So the answer is 1 over 1 plus x squared. So that is the value of y prime. Okay?